Hello, Luke. Welcome to lesson 96. Today we're going to be talking about square roots, really, and how to work with them within equations. All right, so let's go ahead and get started here. Let's start by just reviewing what a square root is so that we have all of that in place in our heads. So let's say I have the square root of 4, for example. What does this mean, right? And if you recall, the square root of a number means that we're asking for, what number times itself, in this case twice because it's a square root, will give me the number within the square root, the 4 in this case. So what number times itself is going to give me 4? That's what the square root means. And we're looking for this number. So clearly here we could say, okay, well, 2 times 2 is equal to 4. All right, so the number that we'd be interested in would be the number 2. So we could say that the square root of 4 is indeed 2. All right, but you might recall that square roots actually have two different solutions. Okay, in this case, 2 is obviously a solution, but another solution would be a negative 2, because if I take a negative 2 and I multiply it by itself, I will also get a 4 as an answer. All right. So there are actually two solutions. We have a positive 2. That's a solution. Also, we have a negative 2. That's a solution. And that's true for all square roots. There's always two answers to that. All right. Now, in the textbook, we've kind of accepted that when they give us the square root of a number and we're simplifying or evaluating, we're going to assume that they are looking for the positive square root if there is a positive sign to the left of the square root. Or if there isn't a sign, we assume that it's positive. All right, so in this case, if I have the positive square root of 4, the answer is 2. The answer is not negative 2. All right, it's a convention that we're using. If there's a positive sign, we're going to assume they want the positive root. If, on the other hand, they had wanted the negative root, they would have had to have written this negative sign outside the square root. And that would be your indicator that they're looking for the negative root for the square root of 4. All right, so the answer here would be negative 2. All right, those are the conventions that we've been using all along. All right. Now, one other thing to point out here in regard to roots, and that is if I have a number such as 3 squared, and I take the square root of that, what's the answer going to be? Now, again, because I haven't written a negative sign out here, you can assume that I'm looking for the positive root of the 3 squared. And if you think about this, 3 squared would be equal to a 9, and the square root of 9 is a 3. Again, we're assuming positive 3. All right, so what happened here? Well, I had 3 squared, and I got 3 as an answer. And this is true for any square root. So if I have 4 squared, and then I take the square root of that, the answer is going to be a 4. Okay? If I have, 100 squared, and I take the square root of that, the answer will be 100. So whenever I have something that's squared and it's inside the square root, I just take the base of that number that's being squared. In this case, it's a 3. In this case, it's a 4. In this case, it's a 100. And I set it all by itself without any square root sign. That is the solution. Okay? All right, so I know this is all review, and you're probably going, okay, I understand all this. I've done it all before. What does that have to do with our workload today? Well, that's the next topic here that we can talk about. So what we will be looking at today is kind of using what we know about square roots and applying it to equations. All right, so if I have something that looks like this, x squared is equal to 4. All right, I'm going really simple here. And if I asked you to solve this, I want you to solve this equation. What is x? You've learned in the past how to do that. And we would do this one by factoring, right? We would start by moving the 4 over to the other side, and we'd have x squared minus 4 is equal to 0, right? And once we have it at this point, we can factor the left-hand side. So we factor the left-hand side. It's the difference of two squares. So we have x minus 2, x plus 2 on the right-hand side. That's equal to 0. And by the zero factor theorem, we know that in order for this to be true, one of these factors, either the x minus 2 or the x plus 2 or both, have to be equal to 0 in order for us to be able to multiply them and get to a 0. All right, so we've talked about this before. So we would have to say that, okay, the x minus 2 would have to be equal to a 0, or the x plus 2 would have to be equal to a 0. And how could this happen? Well, in this case, it would only happen if x is a 2, right? Because if it's a 2, 2 minus 2 is 0. This would happen only if x is a negative 2, right? So the two ways that we can get a 0 out of this product is if x is equal to a negative 2 or a positive 2. And actually, whoops, let me write that right. A positive or negative 2. And remember, this is one way to write that, so I don't have to rewrite the 2. I just write it plus minus, and it just means that x is a plus 2 or a minus 2. All right? And that would be our solution to this equation. Now, that again is review. You already know how to do that. But now, let's think about how to use roots to solve this kind of an equation. So I'm going to do the equation again over here. X squared is equal to 4. But instead, this time, I'm going to say, all right, using this rule over here, we could say that this x squared, if I take the square root of this, okay, what would happen? What would be the square root of an x squared? Well, just like the square root of a 3 squared was 3, and the square root of a 4 squared was 4, the square root of an x squared is going to be x. Okay? Hopefully that makes sense. Now, what do we know is kind of the fundamental rule for equations. What you do to one side, you have to do to the other side, right? I can do anything I want, but I have to do it to both sides. So since I took the square root of this side, I have to take the square root of the other side as well in order to keep this a true equation. So if I take that, you might be tempted to say, okay, square root of 4 is a 2. Why isn't it a negative 2? Well, because there isn't a negative sign out here, right? And you would be right to say that because that's the convention, as we pointed out over here, that's the convention that we've been using all along. Now here is where we're going to kind of part ways from what we've been doing up to this point. And that is this convention, this whole when do you have a negative and when do you have a positive, all right? That will hold when we are simplifying problems, and it'll work when we are evaluating problems, okay? However, if we are solving an equation, we don't go by this rule, all right? If we're solving an equation, we don't go by this, if it's positive, then it's the positive root. If it's a negative, then it's a negative root. We don't go by that rule, okay? When we're dealing with an equation, we need to give both possible solutions for the root. So on the left-hand side, we're going to say that, okay, x squared square root, we're going to say that's equal to an x, just like the way we did this rule, okay? It's a positive out here, so this is going to be a positive x. All right, so that part we're going to keep the same. However, on the other side, we need to state both possible solutions. So even though this is a positive out here, we have to recognize that actually the square root of 4 could be a positive 2 or a negative 2, just as we showed over here. Okay, could have been a positive 2 or a negative 2 for the square root of 4. All right. And then at that point, that is our solution. Okay, so on the one hand, you can see where using these square roots on both sides of the equation is helpful because we don't have to go through all this factoring that we had to do over here to get to our solution of x being equal to plus or minus 2. On the other hand, it's going to take a little bit of memorization, because we need to remember that, on the right-hand side, or I could really say on one of the sides, it doesn't matter which, but it makes more sense to put it on the side that's not the variable side. We need to put the plus minus. We need to take both solutions into account, which is different than what we've been doing all along when we've been simplifying or evaluating. Okay? Then we look at the sign on the outside. This will still continue. Anytime they ask you to simplify, anytime they ask you to evaluate, you will do so based on the sign outside the root. But when you're doing equations, the solution has to be a plus minus for the root. Okay? Hopefully that makes sense. Don't forget that. Equations are different. Okay? Otherwise, you're only getting part of the answer. You're only getting one of the answers when there's actually two. All right? Okay, very good. So that is really the meat of the lesson today. It's not a very complicated lesson. So let's just throw a couple of problems at you. If I have p squared is equal to 25. Now, you could solve this the way you've been doing it before, where you move everything over to one side, set the equation equal to 0, and then factor, and then use the zero factor rule to discern what the p would be. However, in this case, I want you to use the square root rule. Excuse me, the square root rule. So go ahead and pause the video and just try it. See how you do. Shouldn't take you very long, and then we'll do it together. All right, so let's do this problem together. All we're going to recognize is that, okay, this p squared, if I square root this p squared, the solution is going to be a p. Now, you could argue it's going to be a plus or minus p, but remember, we only need to put the plus or minus on one side of the equation, and it always makes more sense to put it on the opposite side of the variable. All right, so what we do to one side, we have to do to the other. So this square root on the other, it's going to need a plus or minus. I might even say, here it is. It's plus or minus square root of 25. I'm going to write it just like that, just to emphasize the fact that really the first thing we need to do is put this plus minus in here. All right, and then we can look at the square root of 25 and say, oh, well, that's actually solvable. The square root of 25 is 5, so we end up with this plus or minus 5. That is what p is equal to. All right, pretty easy, huh? All right, let's try another one. How about if I have q squared is equal to 37? All right, go ahead and pause the video. Try this one. All right, so let's try it out. We recognize again that this is a squared term, and we can basically get rid of the square, if you think of it that way. We can get rid of the square by taking the square root of it, but we have to do it to both sides. So the square root of q squared, that's just going to give me q. But on the opposite side, I need this plus or minus. And then I have the plus or minus square root of 37. Square root of 37, well, 37 can't be reduced. That's actually a prime number. So we don't know what the square root of 37 is in terms of a decimal, but we'll leave it the way it is. So q is equal to plus or minus the square root of 37. It's that simple. All right. Very good. All right, excellent. So I think actually we're good to stop. It's a short lesson. There's not a whole lot to it. But it's important because this will help us solve some of these problems that have squares in them. All right, so good luck with the seat work, and I will see you next time.